Hello, my name's Simon Dennis, and today I'm going to be talking about understanding memory for wear using smartphone data. My collaborators in this work have been Hyung Wook Yim, Elizabeth Laliberte, and Benjamin Stone, and this has been conducted at the University of Melbourne. In 1984, Ronald Cotton was convicted for 2 counts of rape and 2 counts of burglary. He was sentenced to life plus 50 years. Cotton was exonerated in 1995 after spending over 10 years in prison when DNA evidence demonstrated it had been Bobby Poole who had committed the crimes. This case is well known in the memory literature because part of the reason that Cotton was convicted was because there were a series of misidentifications by a key witness, Jennifer Thompson-Canino. So Thompson-Canino misidentified Cotton in an original photo lineup. She then misidentified Cotton in a subsequent in-person lineup. And then 2 years later, when the actual rapist, Bobby Poole, was brought into the courtroom and placed side by side with Cotton, she again identified Cotton. And so this is a classic case of how the choice of someone and that the introduction of misinformation can occur in memory. However, there's another key aspect of this case which has had less attention, and that's that Cotton supplied a false alibi. And of course, that led jurors to the conclusion that he was lying. So instead of remembering where he'd been at the time of the crime, he remembered where he'd been the week before. And so an important question from an applied sense and also from a pure sense is, how reliably can people remember where they've been? What factors affect that memory? And what questions might the detective have asked to uncover the false memory? Now, these kinds of questions we really can't use the laboratory to answer because it's quite critical that we be talking about people's real lives, about real locations that they've been in and so forth in order to be able to answer these questions. So what we did is we went about trying to establish these by actually tracking people using a smartphone. So we used the Unforgettable app, which you can see on the left-hand side of this picture. And the app is on 24/7, and it collects a number of streams of data. So it collects accelerometry, audio, battery. It can collect images, and it also collects GPS locations. And what the system does is it converts that data into an event stream which participants can look at in their account. And so you can see a couple of events here from my own stream. So we augment this information with Street View images, look up the addresses, look for the weather and so forth to get a as complete picture of what that experience would be like as we can. Now, in the first experiment, what we did is we used Unforgettable Me, and we collected for 1 month. So participants were out for 1 month. Accelerometry vectors were collected 10 times a second continuously. So that amounted to about 51 million data points per subject. We had GPS coordinates every 10 minutes, so about 8,640 pairs per subject. And we had audio segments. So these are short 3-second segments of Mel frequency capsule coefficients every 10 minutes. So again, 8,600 points. There was a 1-week retention interval, and then they received a memory test. Each trial in the test included 4 alternatives. So they'd be given a screen like this, and they would be asked a question about where they were at a certain time. So in this case, Thursday morning, 8 AM on August 15th. And so there are 4 alternatives. All 4 of them are places that this particular participant had been. And their job is to choose which of these were the ones they were at that time. In this experiment, people were accurate 64% of the time. Now, what we did is, so we have a series of choices we have, and so we know which of the options people chose, and we know how close each of those options were on each of the different dimensions of interest. So we can calculate a distance between the actual location and each of the options in terms of the accelerometry vectors, in terms of the audio vectors, and in terms of the GPS vectors. We then put that into a Bayesian conditional logit. So this allows us to extract parameters which tell us how important were each of the dimensions for determining the choices that people made. So in this case, what you're looking at are the 95% credible intervals. And you can see that while accelerometry and audio do show some effects, and they're above chance, it's the GPS that is particularly important here. So i.e. close locations were more likely to be confused and incorrectly selected. So that's perhaps not surprising. We were asking where they were for in this case, and so that might be why that would be true. We also looked at categorical time. So to what extent did they choose options that had the same hour of the day, the same week, or the same day of the week? And you can see all of these are highly significant. So the bottom one there, the day of the week, what that indicates is that people are likely to choose options that have the same day of week, even if they choose the wrong week, for instance. So those kinds of errors would be the ones that Cotton committed. So we also ran a second experiment, and the purpose of this experiment, was exactly the same on most dimensions, except in addition, we queried people about their emotions at different times during a 14-day period. So in addition to Unforgettable Me, we used the CIMA3 app to prompt them 8 times a day about how they were feeling on 11 discrete emotions. So this is a replication and extension of the first experiment, and people were accurate about 67% of the time in this case. We can look at each of the discrete emotions and see, again, using the conditional logit model to see to what extent that emotion or differences on the scale in that emotion predicted responses. And you can see all of these are highly significant, and with the positive emotions being a little bit more telling than the negative emotions. We also just did a normal logistic regression looking at and combined the emotions together to look at the overall impact of different kinds of emotions on accuracy itself. And so first interesting point about this is that negative emotions did not have a significant impact on accuracy. However, the positive emotions did, but in a somewhat surprising way. So positive lower arousal emotions like relaxed or content showed a large positive effect. The positive high arousal emotions like excited showed a negative effect. So that's a little bit perplexing. I would have expected the higher arousal emotions to have the positive effect, if anything, but that's not what we found. The positive low emotions, that might occur because the times when you feel those kinds of emotions might be just when you're kind of chillaxing at home. That's a high probability event, and therefore one that you might tend to guess commonly. So that might explain why that we receive that, or why we see that result. So in conclusion, after a 1 to 5 week retention interval, people are able to identify where they have been about 2/3 of the time. So that's an important applied result. It allows us to get a sense of how likely are the kinds of errors that Cotton committed. Distractors that are similar in location or in categorical time, same time of the day or same day of the week, are more likely to be chosen. And distractors that have similar emotional contexts are also more likely to be chosen. Negative emotions at the time of encoding do not seem to predict accuracy, but low arousal, but positive emotions do, with low arousal positive emotions associated with better accuracy, and high arousal positive emotions associated with worse accuracy. Thank you very much.